Given a input string, we need to find its longest palindromic substring. For example, in the string BABAD, BAB and ABA will be the longest palindromic substrings. Let's solve this problem first using brute force approach in big O of n cube. Using two pointers I and j, we can check whether the substring from I to j is a palindrome or not, and keep on updating the resultant string and max length as specified in the mentioned steps. Using two pointers, let's define the isPalindrome function and keep on checking the substring from I to j inside the nested loop for the output. We can update result and max length if the difference between I and j is greater than max length and a substring from I to j is a palindrome and its length is greater than current max length. Let's solve using dynamic programming in big O of n square. Initialize n as string length, left and right variables as 0, max variable as integer dot min underscore value. Initialize 2D boolean dp array as shown in the image. Please have a look at the steps. I will explain them in next slide. As you can see in the shown image, we will traverse I from n-1 to 0 and j from I to n. For each I, we will traverse j from I to n. Let's say if I is 2, we will consider j as 2 and 3 since n is 4. dpij represents whether substring from I to j is a palindrome or not. There are following three edge cases. If I is equal to j, dpij will be true since a single character will be a substring of itself, hence we can mark the left diagonal values with true as shown. Else if si equals sj, we have two conditions. If j minus I is equal to 1, dpij will be true since string of length 2 will be palindromic. Else if j minus I greater than equal to 2, we can rewrite it as j minus 1 greater than equal to I plus 1. We need to check whether dp I plus 1 j minus 1 is palindromic or not, hence we will equate this to dp ij. For each iteration, we will update I and j if dp ij is true and j minus I is greater than equal to current max. dp I plus 1 j minus 1 means next cell in the right diagonal. Hence, I highlighted the cells during each iteration with red and sky blue colors. As you can see in image for first iteration, we will consider one cell in the bottom, then 2, 3 and 4 in subsequent iterations in bottom-up manner. We can memorize the blue highlighted left to right or rotated histogram pattern formed for framing the logic. Let's code using the logic we have discussed. Using Manacher's algorithm, we can solve the problem in big O of n. It uses palindromic string properties. We can use previous results during computation. We will use a LPS array for computation. As we can see in the image 1, C is centered in the palindrome and LPS array values of characters to the right of C can be filled out right away using the inverted mirror formed because of palindromic nature. In example 2, palindrome around A pointed by the arrow cannot be assigned LPS array values straight away. Since mirror A palindrome exceeds the range covered by palindromic substring CACAC, we transform our string by placing slash in between the characters so that palindromic center can easily be obtained using the string of odd length. Let's say C is the correct center and R is range. LPS is the array we were using to count the number of matching characters around a center. Here are the steps. Wrap input string with slash character, initialize int array of length n, C as 0 and R as 0. Iterate from I to n for each I. Set inverted mirror variable as 2C minus I. Update LPS using minimum of inverted LPS value and difference between range and current index. If range is greater than current index, else set LPS I as 0. Check palindrome around I using while loop and increment LPS I with 1 as long as the current mirror forms and the current character. I plus 1 plus LPS I and I minus 1 minus LPS I represents right and left characters of the palindromic mirror. At last of each iteration, update C and R if I plus LPS I is greater than the current range. Return substring from C minus R to C plus R excluding slash characters. Thanks for watching. Have a nice day. Happy Ganesh Chaturthi. Please like, comment, share and subscribe to my channel, and feel free to follow me on various social media platforms using the links specified in the video description.
People working anywhere in the world, born anywhere in the world, can create a product and make it available to anyone in the world. The most used messaging app in Southeast Asia was built by a young man born in Ukraine who moved to the US. And the 3 most popular viral games in the US in recent years came from entrepreneurs in Finland, Ireland, and Vietnam. You're the ones building the next Google, the next Spotify, the next Tesla, the next, well, we don't even know, but what I know is it's the idea that matters. It didn't matter where you come from or what your background is. One revolutionary idea, one brilliant invention can unleash other entrepreneurs to revolutionize industries in ways you could never predict.